Every generation of silicon demands more from your layout, as BGA pitch shrinks to 0.5, 0.4, and even 0.35 millimeters. Available routing space is defined by microvia structures, fabrication limits, signal integrity, and thermal behavior. In Allegro X, HDI begins in the cross-section editor, where stackups are defined to match fabrication constraints and drive impedance, routing, and via definitions. Blind, buried, and via in-pad microvias are defined using the pad stack editor. The blind and buried via editor defines microvia stacks across layers for stacked and staggered via configurations used in HDI designs. These rules are managed in a unified constraint manager, where spacing, via structures, and pad rules are centrally defined and enforced in real time across the design. For BGA fanout, constraint-driven routing controls breakout channels, layer transitions, and via selection within defined electrical and fabrication constraints. During routing, Allegro X continuously evaluates DFM constraints, copper distribution, thermal connectivity, and return path integrity, enabling early detection and correction of manufacturability risks. With in-design analysis, engineers can validate signal integrity, return path behavior, and power integrity directly within the layout, with seamless integration to Sigrity X solvers for sign-off. Allegro X enables HDI designs to progress from stack-up definition to analysis and verification within a unified environment, reducing iterations across layout, simulation, and manufacturing.